Okay, we're given this set and asked to verify that it's orthogonal. Okay, well, it's clearly orthogonal. Dot product of this with this is 0, dot product of this with this is 0, dot product of this with this is 0, and that's trivial to calculate. So I'll say, yep, it's orthogonal. Now we want to make it orthonormal. Orthonormal is the same thing as orthogonal, except all the vectors have to be unit vectors. So you get a bunch of orthogonal unit vectors. Well, magnitudes of these vectors, and you can work it out yourself. Magnitude of this one is square root of 3. Magnitude of this one is the square root of 14. The magnitude of this one is the square root of 42. So your basis, your orthonormal basis B, the basis that we want to get, is just going to be, as you see it here. Divide each vector by its magnitude. Then rationalize your denominators. Well, divide through and you get this, rationalizing your denominators. And you can write this out very easily. If you don't know how to rationalize a denominator, now's a real good time to learn. You should know this. It's a standard form. It puts things into a standard form that you can read easily and quickly without having to do a lot of figuring if you're used to that standard form. Okay, anyhow. Now this is then an orthonormal basis. These vectors are still orthogonal because if a vector is orthogonal to another one, it's orthogonal to any multiple of that vector, since multiplying a vector by a constant doesn't change its direction. So if it's orthogonal, if you double its length, it's still orthogonal to whatever it's orthogonal to. Okay. So now we're going to call this basis V1, V2, V3. Okay. I've got a question up here. There's something I've written down here that I don't particularly like. But what we're going to do, and we'll do this next, is we're going to take an arbitrary vector V, call it x1, x2, x3, just general coordinates, and we're going to calculate the representation of the vector V with respect to the basis B. Okay, so we're going to do that next. I want to check out one thing here.